Yeah, good afternoon, everyone. My name is Peter. I'm one of the partners of Kapernikov. Thank you for joining this session. I would like to begin with a quote from the CEO of Beaulieu, who quoted that technology should be used to avoid repetitive work and that people should be engaged to take up a more challenging role. And today I'm going to present a couple of cases where Kapernikov took this advice into practice. So first of all, what you see here, imagine that this would be your job. From 9 to 5, you're filtering good and bad cherries on a conveyor belt. So these are exactly the people I want to make their lives more interesting. And I did spare you guys a little bit today by showing this picture. I could as well have shown how garbage sorting works in practice, but I didn't want to do that just after lunch. Here we're looking into the heart of an optical sorting machine. This is a free-fall sorting machine created in Hasselt by Optimum Sorting. And these machines exceed human capabilities. They are ultra fast, and also they can filter based on properties we cannot even see as a human being. That is, hyperspectral imaging allows, for example, to separate a nut that is rotten inside from a good nut. Kapernikov is a software partner for Optimum Sorting, and what these machines do is actually filter good and bad products, but also find contaminations like a rock, a piece of glass, or even an occasional rabbit leg, because that also happens, for example, with vegetables coming from the field, you can imagine. The display of this machine just allows the operator to fine-tune the artificial brain which is inside the machine. A next example, if there is an electronic device in your pocket right now, there is a big chance it will end in the smelter oven of Umicore. So what happens is, all those electronic devices are melted, and then they end up in a pot, like the ones you can see here on a cooling field, to solidify. Now, manipulating these pots is a dangerous job, because of the temperature, because of the atmosphere in general. So Umicore is in fact a company. They want to build a comfortable workspace. They want to have a safe environment for their employees. And to have more control over the predictability and the risks on such a cooling field, the key parameter is to know the exact temperature of the pots on such a cooling field. Now, after the project of Kapernikov, Umicore now has this data, has a display showing the duration of stay of pots and the temperature evolution, in fact, of each and every pot on such a cooling field. All right. So what's behind the scene? In this case, it takes a lot of effort to place a camera and to mount a camera in this environment. So we made a simulation to see how the field of view of each camera would be, and to find the optimal position to have the least possible cameras to install. Then we captured the visual camera stream of this camera you can see here, which is a combination of visual and thermal, and also pan-tilt zoom, so the camera can be directed and zoomed in. And after writing an AI brain to detect where the pots are in the visual stream, we just pick the temperature from the thermal image, and there we have our data to send to a central place. Voila. I have another riddle for you. INFRABEL has 3,800 kilometers of railroad in Belgium alone. And I was wondering if you know how you would organize figuring out what signals may be defective, invisible by vegetation, and what vegetation grows too much that it becomes dangerous, for example, the neighborhood of high voltage lines and so on. See, the point is, in the past, there was only one possibility. Put people in cars, let them drive around, let them enter the secured area along the tracks, and file a lot of reports all day long. All right? This is the new way of working, let's say. This dashboard is one central point where somebody that plans the maintenance operations has all the information together, and they can filter on area, location, and on severity of the incidents. All right? Here again, yeah, how we do this? By collecting data, in this case a lot of data, like 2.2 gigabytes per kilometer railroad, times 3,800. We write algorithms to parse that 3D depth data very fast, and then we built, together with INFRABEL, a cloud platform to process the data on their premises, and the result is a user interface that is very fluid, whereas a lot of data behind it. All right? From all the things I mentioned, this is the last case. This is actually a job I would consider doing myself. Looking at the process of filling a ship with fertilizer. Being outside, the nice weather, you get the picture. Unfortunately, loading such a ship can take up to a couple of days. So you need to be out there any time of the day, and you need to be careful as well, because sometimes contaminations are dropped in the ship, and if that happens, somebody needs to go in the ship to take the contaminations out. If they get buried under, actually the entire load of the ship decreases in value. So that we want to avoid. But the speed of such a conveyor belt system going towards the ship is too fast for a human being to see what happens, what passes by. So the question was, could Eurochem build a camera system to monitor upstream and stop the conveyor belt in time, so that they can easily just take out the contaminations from this belt system? I wouldn't bring this case, of course, if the answer was no. So yes, Kapernikov built a camera system monitoring this flow on the belt. Then you get data, images, and a camera can actually picture something very sharp that goes very fast in reality. An AI project means data collection, annotating contaminations, and training a network, deploying it on site, and in this case, mainly the optical electronics need to be packaged in a setup very carefully, because it's outside. You have temperature variations, giving moisture in the lens system, and a lot of dust. So that is also something we can cover. So far for the cases, let me end with a little bit of introduction. What is Kapernikov exactly? Well, this is our skill set. This is what we master. And our job is, in fact, to build a team that can keep up with technological evolutions over time in software development, in all the skills we need. We've learned today that machine vision can make the life of an operator more comfortable. In fact, the job of Kapernikov is to please our software engineers, to give them an environment that they like to work in. And that means, in practice, they want to be confident if they deploy software on Friday afternoon, that it will be a good release and stable. And the second thing is, if they can work together and learn from each other while doing great projects with an impact on society, that's our goal. So to end, if you feel inspired about these cases, feel free to join us on our booth, which is on the opposite side of this hall, or contact us afterwards. Thank you for your attention.